Perkenalkan nama saya Vicentius Ronaldo Angga Kuzumatalu. Then talking about graphs includes, so this is just a mathematical sentence, very few people know who understand it, maybe they know the picture, maybe they can't find the word in the English dictionary of mathematical terminology. Mathematical terminology is not explained in detail but only makes sense. Imagine the imagination encompassed by this great graphic. This is a small one, so look, there's a lot of everything. For example, there are 4 numbers, the number 1 appears 4 times and each number appears 4 times here, and also this V has it the same number or with the same number, namely the number that shows arrangement between the top of the bottom of that situation. Cover excellent speech and cover graphic. Cover is a method to create a very great network from the small to the right, which is images that cover, so they cover this. For example, we can find a triangle as a long cycle. There are 5 3 5 3, so that's a very big cycle that covers this cover. So this is concise triangle 1 5 3 1 5 3 4 times, that is cover. Also this is another cover. There are methods for creating very large networks from very small networks. The graph is very big. The big graph covers the small graph, so what can we say about the big graph? Just look for these little guys and never miss one. And basically, if a very large network has that kind of cover structure, so that we can create some algorithms that are very fast to discover a lot of things. So because it's small, we can easily check everything from the big the small ones and the ones that are lifted in the big ones, so we can find some objects we want on time. Planar cover conjecture 1986. If a connected graph G has a finite planar covering, then G has a two-fold planar covering. Seiya, a pure mathematician, he created a new field in 1955 which included topological graphs. After he arrived at Dori, he wanted to start a new subject and he got inspiration from God, then he changed institutions and got B. Then he read, Joka, he has limited planar cover, so it can be embedded in the plane of the pliers in the projection. Maybe it's easy. Plane projects don't exist in this room. These words exist in the four-dimensional world, so we'll skip the explanation. If a non-connected graph has a finite field that includes it. This image is a network that we call a graph that has 5 signals and is connected by edges, but we have intersections here. So it doesn't function as an electrical circuit because there are cross signs, for example a sign like a cross whose crossing is unpredictable, so this is impossible. Take an example like this, there is no intersection, B with number 1. If I find a very large network, a network that includes small ones, then we can find small ones of only 2 or 4 very small sizes. This is Seiya's guess. That's the end of Seiya's explanation because he didn't want to explain in more detail. Explain. A small graph and a slightly big graph, it's covered two-fold. In two-fold we can get another one, and we have the very big one. This is a 4-fold and this is 2-fold, and that has a very long R psych L, it's cover this one too. So this covering can be decomposed into 2 things, this situation called composite covering, right? So there is some terminology appears. So this is a small guy given 1 and the small covering and the big covering, that's that covering. I'll cover this one and passing through this one that. Intermediate double coverings. Theorem 1, if M is an odd number, then M2, composite covering has a unique double coverings, up to equivalence.